Hello and welcome back to Math 1324. We are starting Chapter 5, Linear Inequalities and Linear Programming. In this first section should be a review on how to graph linear inequalities in two variables. Okay, let's go start with Section 1, Graphing a Linear Inequality. Some definitions. A line in the coordinate plane divides the plane into two regions called half-planes. First vocabulary word is half-planes. A vertical line divides the plane into left and right half-planes, whereas a non-vertical line divides the plane into upper and lower half-planes. That dividing line is called the boundary line of each half-plane. All right, theorem. The graph of the linear inequality ax plus by equals c, the graph of the linear inequality ax plus by less than c or ax plus by greater than c, as long as b is not equal to 0, is either the upper half plane or the lower half plane, but not both, that's determined by the line ax plus by equals c. If b equals 0 and a is not equal to 0, then the graph of ax less than c or ax greater than c is either the left half plane or the right half plane, but not both. That's determined by the line ax equals c. All right, so the procedure for graphing linear inequalities. The first thing you're going to do is go graph the line ax plus by equals c. Then you're going to graph it as a dashed line if the equality is not included in the original statement. In other words, it's dashed if it's either just this or just that. Or you're going to graph it as a solid line if the equality is included. So if you have less than or equal to or greater than or equal to, it's a solid line. Second step, choose a test point anywhere in the plane that's not on the boundary line. And I will tell you the origin usually requires the least amount of computation. Substitute that test point into the inequality. If the test point satisfies the original inequality, then shade the half plane that contains the test point. If not, then shade the opposite half plane. We're going to go do some examples. I want you to graph the inequality 2x minus 4y less than or equal to 8. So I'm going to do the equality 2x minus 4y equals 8. And I'm going to go graph this by using the intercepts. So if y is 0, I have the equation 2x equals 8, so x would be 4. If x is 0, I have the equation negative 4y equals 8, so y would be negative 2. So I'm going to go plot those 2 points, 4, 0, and 0, negative 2, 4, 0, 0, negative 2. I'm going to go, let's see here, up 1 over 2, up 1 over 2. All right, since it's an equal to, my original one has the equal to, it's going to be a solid line. Now the last thing, I've got to do a test point. I'm going to pick 0, 0, because that's not on my line, my boundary line. If I plug in 0 for x and 0 for y, I get 0 less than or equal to 8. That is a true statement. So I want to color the half plane that contains 0, 0. So I'm shading this half plane. Number 2, I want to graph the inequality 6x minus 3y greater than 21. So I'm going to do the intercept method again. 6x minus 3y equals 21. If my y is 0, I have to solve 6x equals 21, so x is 3. If my x is 0, I have to solve negative 3y equals 21, so y is negative 7. Sorry about that. Okay, so I'm going to plot 3, 0, and 0, negative 7. 6, 7, 6, 7. Okay, since it's just greater than, there's no equal to. This is a dashed line for my boundary line. Now I need to pick which side to shade. If I use my test point 0, 0, is 0 bigger than 21? That is false. I do not want to shade that point 0, 0. So I'm going to shade this half plane. Number 3, I want to graph y less than 3. How do you graph the corresponding equation y equals 3? That's a horizontal line here at 3. Since it's just less than, there's no equal to, it's going to be a dashed line. Okay, so my test point is 0, 0. If I plug 0 in for y, is 0 less than 3? Yes, that's a true statement. So I want to shade the half plane that contains the origin. I want to shade down this way. Number 4, I want to graph the inequality 3x greater than 15. If I do the corresponding equation, 3x equals 15, and divide both sides by 3, I want to go graph the equation x equals 5. That is a vertical line, 1, 2, 3, 4, 5, right here. Since it's just greater than, and there's no equal to, then my boundary line will be dashed. Now choose a test point. I can pick 0, 0. If I plug 0 in for x, 3 times 0 is 0. Is 0 bigger than 15? No, so that's a false statement. I do not want to shade the half plane that contains 0, 0. So I'm going to shade to the right. Number 5, I want to graph the inequality 5x greater than or equal to 10y. So I'm going to graph the corresponding equation 5x equals 10y. If I divide both sides by 10, I get y equals 1/2 x. Okay, that's in slope-intercept form. Y equals 1/2 x plus 0, correct? Okay, so my origin is the y-intercept. I want to use my slope up 1 over 2 to graph more points, or down 1, left 2. Okay, since it is an equal to here, it's greater than or equal to, my boundary line is a solid line. All right, now for a test point. You see that the origin is on your boundary line. You can't pick the origin for a test point. So I'm going to go over here and pick 2, 3, 4. I'm going to pick the point 5, 0. You can pick any point on the coordinate plane. I chose to pick 5, 0. I'm going to let x be 5 and y be 0. So 5 times 5, is that bigger than or equal to 10 times 0? So is 25 bigger than or equal to 0? Yes, that's a true statement. So I want to shade that test point. I want to shade the half plane that contains that test point. Okay, now we're going to kind of go backwards. I'm going to give you the graph, and I want you to write the inequality from the graph. Okay, first thing we need to go find is the equation of the boundary line. What is the equation of that boundary line right there? Y is going to equal negative 1, 2, 3. So y equals negative 3 is the equation of that boundary line. But I don't want the equal to in there, and I want all of the values of y that are bigger than negative 3. So my inequality is going to be y greater than negative 3. That's the inequality. All right, number 2, write the inequality from the given graph. This boundary line is an x equals something, and it's x equals, what is that, 2.5? And for my inequality, it's a solid line, and it's all the x's that are less than or equal to 2.5. That's my inequality. X less than or equal to 2.5. Number 3, write the inequality from the given graph. What is the equation of this boundary line? Okay, it's going to be y equals, okay, to get from this point to this point, what's my slope? I've got to go down 1, 2, 3, 4, 5, 6. So it's going to be negative 6 over something. 1, 2, 3, 4, 5, 6, 7, 8. So my slope is going to be negative 3/4. So y equals negative 3/4 x, and then plus y-intercept is 6. Now for my inequality, here's another thing. If you're shading the bottom part of the y-axis and you have it in slope-intercept form, your inequality is going to be y less than or equal to negative 3/4 x plus 6. That's just another trick. If you've got it in slope-intercept form and you're shading down below the bottom of the y-axis, this one is the less than, and this one is the greater than. That might help you some too. So my inequality is going to be y less than or equal to negative 3/4 x plus 6. It's equal to because this boundary line is solid. All right, number 4, write the inequality. Okay, what's the equation of that boundary line? Y equals, I'm going to go down for the slope, down 1, 2, 3, 4. So negative 4 over, and then I'm going to go to the right, 10. So my slope is negative 2/5. So the equation of that boundary line is y equals negative 2/5 x plus the y-intercept is 4. Y equals mx plus b. All right, remember that I said that if you shaded the bottom part, it would be the y less than mx plus b. If you shaded the top part of the y-axis, it's y greater than mx plus b. So the equation of my inequality is going to be y greater than negative 2/5 x plus 4. Notice it's not equal to because this boundary line is dashed. So we're going to do a couple of application problems. A food vendor at a concert sells hot dogs for $4 and hamburgers for $5. How many of these items must be sold to produce sales of at least $1,000? Express the answer as a linear inequality and draw its graph. All right, I'm going to let X be the number of hot dogs sold, and I'm going to let Y be the number of hamburgers that are sold. Okay, notice that hot dogs sell for $4, hamburgers sell for $5, and you want at least $1,000 sold. If I sell X hot dogs for $4 each, and I sell Y hamburgers at $5 each, I want that amount of money to be at least, so greater than or equal to 1,000. There's my inequality that I need to graph. All right. So I'm going to go back to, let me write the corresponding equation. Oops. So the corresponding equation is 4x plus 5y equals 1,000. And if I graph by intercept method, if y is 0, I get 4x equals 1,000. So x is equal to 250. If x is 0, I get 5y equals 1,000. So I get y equals 200. All right, here we go. Let's do by 50s maybe. 50, 1, 50, 2, 250. 50, 1, 50, 2. All right, so I have the point 250, comma 0. So 250, comma 0. And the point 0, 200. I'm going to go ahead and label those. All right, because it's greater than or equal to, that line is going to be solid. Now I want to do a test point. So if I pick 0, 0 as my test point, if I plug 0 in for x and 0 in for y, I get 0 greater than or equal to 1,000. That is not a true statement. That's false. I do not want to shade the half plane that contains 0, 0. So I want to shade this half plane. But I want you to be careful. You can't have a negative number of hot dogs and hamburgers. So when you shade, you need to stay here in the first quadrant and just shade that region. Do not shade over here or down here. Number 2, a farmer wants to use 2 brands of fertilizer for his corn crop. Brand A contains 26% nitrogen, 3% phosphate, and 3% potash. Brand B contains 16% nitrogen, 8% phosphate, and 8% potash. How many pounds of each brand of fertilizer should he add to each acre if he wants to add at least 120 pounds of nitrogen to each acre? Okay, I'm going to let X be the number of pounds of brand A, and I'm going to let Y be the number of pounds of brand B fertilizer that need to be added. All right, I want 120 pounds of nitrogen. Brand A contains 26% nitrogen, and brand B contains 16% nitrogen. So my inequality will be 0.26x plus 0.16y, at least 120, so greater than or equal to 120. So if I go do my intercept method, If y is 0, 0.26x equals 120. I'm going to do 120 divided by 0.26, and I get 461.5. If I let x be 0, I get 0.16y equals 120. So 120 divided by 0.16 is 750. So I have a y-intercept of 750 and an x-intercept of 461.5 approximately. Since the inequality is greater than or equal to 120, it's a solid line. Okay, if I plugged the test point 0, 0 in, I would get 0 bigger than or equal to 120. That's false. I don't want to shade 0, 0, and I want to keep these axes. If I can't have negative amounts of fertilizer, my answer would be this shaded region up here. All right. Second part of the problem says how many pounds of each should he add if he wants to have at most 28 pounds of phosphate. Okay, for the phosphate, brand A has 3%, brand B has 8%, and you want at most 28 pounds. What was brand A again? 3%. So 0.03x plus 0.08y at most, so it has to be less than or equal to 28 pounds. If I do the intercept method and let y be 0, 0.03x equals 28. I get 933 1/3. If I let x be 0, I get 0.08 equals 28. So 28 divided by 0.08 is 350. So if I do 350 on my y-axis and 933.3 on my x-axis, that's where my points are, it's less than or equal to, so it's a solid line. Okay, pick a test point. So I'm going to pick 0, 0. Is 0 less than or equal to 28? The answer is yes, that's true. I want to shade the half plane that contains 0, 0, but again, I have to stay positive x and positive y because I can't have a negative amount of fertilizer. So there's the feasible region for, or that's the graphical solution of this inequality. And that's it for this section. Go practice the homework or go complete the homework, and we'll see you next time.